Okay, everyone. So now we are on what are called truth tables, which are, I think, kind of fun. They serve as a way to generalize basically the ideas that we just covered. So now instead of using like very specific statements and um, to have a lot of words in them, we're just going to use the letters sort of like variables and assume that they could take any value. And then from that, we're going to derive the truth value of negations, conjunctions, disjunctions, and combinations of all of them. So let's basically see what's going on here. So let's start with the negation table. Well, we notice that there's two columns. The P column, which is already filled out with true and false, and the not P column, which is blank. So we have to fill out the not P column. The P column is filled out because P can only have two possible values, true or false. The not P column is depending on the results of the regular P column, because you don't know what not P is unless you know what P is. So let's look at that. In the first row underneath the P, we have true. P is true in that little row right here. So if P is true, then not P always takes the opposite value, so we would fill in false in this part of the row. Because, again, opposite value. If P is true, not P is false. So then on the last row, we have that P is false, so not P would be true in that case. And there's the most simple truth table we can really work with. Now, let's look at the conjunction truth table. So we have P and Q, because in conjunctions we use two statements. And it doesn't matter what P and Q actually, like what statements they actually are. We just know that they can only contain two values, true and false. But between the two of them, there's four possible outcomes we could have. Four possible combinations. So if we look again at the P and Q column, right? One outcome is that both of them could be true. That's this row right here. Or what if only one of them is true and the other is false? Well, then we could say that P is true and Q is false. Or we could have that P is false and Q is true. Those are another two possible outcomes. Again, we don't really know precisely what they are, but we don't care because we're just listing what every possibility that they could be. And then finally, the last possibility would be that both statements are false. Now, depending on these situations, we can determine the values of what their conjunctions would be. So that's the P and Q. Well, we know conjunctions are true only when both P and Q are true. So this top row, P is true, Q is true. That means the conjunction would be true since they're both true, P and Q. In the next row, we have that P is true, but Q is false. And in a conjunction, they both must be true for the conjunction to be true. Since Q is false, the conjunction is therefore false. Same thing with the next example. P is false, Q is true. That means the conjunction's false. And of course, when they are both false, the conjunction's absolutely false. So that's the basic gist of the conjunction table. We can see now clearly that conjunctions are true only when both of the component statements P and Q are true. With the disjunction, it's true when at least one of the statements is true. Or I like to say when there's a single true statement, then the entire disjunction will be true. So let's look at that. Again, the first two columns, the P column and the Q column, we're just listing out every possibility. They're both true, or one of them's true, one of them's false, or they're both false. And then depending on each situation, we'll determine the truth value of their disjunction, the or statement. So, if both P and Q are true, then disjunction will be true. If P is true and Q is false, hey, in a disjunction, you only need one true for the disjunction to be true. And since P is true, that means P or Q is true as well. Same thing with the next example. P is false and Q is true. That means our disjunction is true. But when they're both false, of course, the disjunction must be false in that case. So it's kind of like, almost like, I wouldn't say opposite because it's not necessarily true, but we can see, like, in the conjunction table, we have one true and three falses. And in the disjunction table, we have three trues and a single false. So now that we have gone over these basic truth tables, the generalizations of all that terminology we went over, in the next video, we'll cover specific examples of sort of different situations where we can combine two or three statements together and form different results from that. So I'll see you in the next video.